To begin our unit on exponents, we're just going to review some basics on what exponents are and how we work with exponents. So our example is 2 cubed, or 2 to the third power, equals 8. And this means we've got the base 2, this is called the base. We got the base 2 3 times being multiplied. So 2 times itself 3 times. And that is where the 8 comes from. 2 times 2 is 4. And then 4 times 2 is 8. So what it does not mean is we're not taking and multiplying those two numbers, 2 times 3. It means we're taking the base times itself, however many times the exponent tells us. So if we go down to the bottom here, we have 10 to the 4th. So that means that we have 10 times itself 4 times. But a shortcut for multiplying by powers of 10, instead of having to multiply all this out 10 times 10 times 10 times 10, instead the shortcut is it's going to have a 1 with the exponent tells us how many zeros. So 4 zeros. 1, 2, 3, 4. And we go back, and every 3 we put our comma. So that means 10 times 10 times 10 times 10, or 10 to the 4th, is 10,000. So that's a shortcut that we can use here. And if you forget that shortcut, then you can just multiply it out. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. Okay, the most important thing that we're going to go over and review in this lesson is negatives. So on this left side, the negative is not part of the base. That would be a problem that looks like this: negative 2 to the second. The negative sign is out in front of the 2, but that exponent of 2 is only on the base of 2. On the other hand, if we do want the negative to be part of the base, if it is part of the base, we need to put that in parentheses. So now on this one we have that exponent of 2 is applied to everything inside the parentheses, so negative 2. So this one would mean negative 2 times another negative 2. But the one over here means I have a negative, and we can call it negative 1, and then I'm multiplying 2 times 2. So we can almost think of this left one as having a negative 1 times 2 to the second. So when the negative is inside of parentheses with the exponent on the outside, that means the negative is included, and there'd be 2 negative signs. If the negative sign is not in parentheses, that means it does not get that exponent. So there's actually only 1 negative sign that we leave and treat it as a negative 1. So an extra example is if I have negative 3 to the second, this means I've got that negative sign, which we can put a 1 in front of it, and then I have 3 times 3. So this answer would be negative 9. If I did put that in parentheses, this means I've got negative 3 twice, because the exponent is 2, and that's going to give me a positive 9. This is especially important when our exponent is even numbers like this: 2, 4, 6, 8, any even number exponents. If the exponent is odd, then it won't make a difference. They're going to be negative regardless. So let's look at a couple examples we can do. Write each product as a power. So on this first one, I have the base of 4 multiplied by itself 1, 2, 3, 4, 5 times. So 4 to the 5th power. Number 2, I have a base of 2 ninths, and it's being multiplied by itself 1, 2, 3 times. So the exponent is going to be 3. This gets really tricky though, because if we just write it like this, it looks like the 3 is just on the 2, but we want this whole thing 2 ninths to have the exponent. So just like the negative, if we want the whole 2/9 to get the exponent, we have to put it in parentheses. So we can see that that 3 goes on the 2/9. And then a key for this one, if the negative is in parentheses, we should leave it in parentheses. And then there's 3 of those, right, without using exponents. So again, when the negative is in parentheses, we should write it using parentheses. That is the easiest way to make sure we remember when it's included and when it's not included. So I have -4 3 times. And now here I've got -7 to the 5th, but that negative sign is not in parentheses, so I don't want to put it in parentheses. 2, 3, 4, 5 sevens. Or I could put that as a -1 times all those 7s. And then the fraction one, so I've got 5 7ths 4 times. Now in this case, if I were to remove the parentheses, it wouldn't make a difference, but it's not a bad idea just to get used to putting in those parentheses. On this last section, we're going to evaluate. Evaluate is another word for solve. So if it says evaluate, we're going to actually solve it. So these first 2 sets of directions did not tell us to solve it. So 2 5 times, 3, 4, 5, and we're going to evaluate. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2, that means that's going to be 32. And then here's another negative, but that's not in parentheses. So we've got this negative or -1 outside. Then I've got 4 3, so I can do, we'll worry about the -1 last. 3 times 3 is 9. 9 times 3 is 27. And let's see, 27 times 3, 3 times 7 is 21, 6, 81. And then I still have to bring down this -1 we haven't used yet. So we get -81. And then this negative is in parentheses, so we have -5 times itself twice. And -5 times -5 is positive 25. And then for our last problem, we've got 2/3 times 2/3 times 2/3. So we have 3 times. And then just like we multiply fractions, we multiply all across the top. So 2 times 2 is 4, times 2 is 8. 3 times 3 is 9, and 9 times 3 is 27.